Okay, so let's get started. We're going to be taking a look at setting up and working with individual throttle body tuning on a naturally aspirated engine using our Motec M1 programming. Now, things are quite different when we're talking about individual throttle body tuning. When we're talking about a single throttle body with an intake manifold plenum, we'll find that we have a relatively linear relationship between our throttle angle and our manifold pressure changes. Once we switch over to individual throttle bodies, we're going to have a completely unlinear relationship. And that's going to mean that as we give some throttle input, we'll find that our inlet manifold pressure may go from something like 30, 40 kPa vacuum at idle all the way to 100 kPa almost instantly. And as a result, we'll have unpredictable fueling. So we're not going to have consistency and repeatability in our fueling to the engine, and even spark timing can be compromised. So when we're talking about tuning individual throttle bodies with a naturally aspirated engine, we have to come up with a different strategy. If you're familiar with tuning with other standalone systems such as M-Tron, Link, AM Infinity, Haltech Elite, you'll find that those give you the ability to actually calibrate and tune your engine efficiency VE table based on throttle position. We can see that we're utilizing inlet manifold pressure versus engine speed in this particular firmware that I'm using, which is a GPRP package. If I click A here, I can't even go into my axes and change this to throttle position. We're fixed on engine speed, inlet manifold pressure, and we can introduce ambient pressure here as another axis option, but we can't do this based on throttle position. So this leads us into going in and getting creative with how we actually set up a Motec in order to work with throttle position or alpha end style tuning. Let's go ahead and click OK here. So what we'll find is, and we talked about in our last training module, we're going to go in here to our estimate tuning table and actually utilize this in terms of calibrating our engine for our airflow with this alpha end strategy. We know that this table here is based on engine speed versus throttle position. The values in here and the normal orientation. So when we have the normal orientation here, we have our volumetric efficiency table, we dial this in, then we can go into our estimate table here. This acts as a backup fail-safe to our inlet manifold pressure. So if something happens with the map pressure, becomes unplugged, sensor fails, there's some kind of a wiring problem, it'll reference what the inlet manifold pressure estimated value is at a throttle angle and engine speed. Now we're going to use this to actually feed into the percentage of cylinder filling instead of referencing our engine efficiency table here, volumetric efficiency table. So we're going about things in a completely different manner here within Motec's firmware package. Other firmware packages with Motec, third-party packages, you may be able to directly configure inlet manifold pressure to throttle position, but with these Motec packages, you have to do this ITB-based tuning in a very specific way. So the first step here, we're going to take a look at setting up a naturally aspirated engine. We'll cover a boosted engine in the next training module. We have to go in and do things in a very specific orientation in order to make sure that everything is going to calibrate correctly and that we're referencing our estimated tuning table here properly, and that we're going in here to something like our ignition timing table here, and our engine load normalized is going to be referenced in something like throttle position, referenced in a very specific way. So we need to go in and configure the details. What I'm going to do here is just walk you through all of the setup and configuration details, and then talk about the general strategy for calibrating and tuning a naturally aspirated engine. It's very straightforward and simple, but again, we need to pay attention to these very, very important details. Let's jump into our fuel tuning, and we're going to go here to our engine efficiency. We're going to turn this into just a singular cell value, so we're not going to have a three-dimensional table, and then set that singular cell to 100% volumetric efficiency. Let's take a look at how we're going to do this. Click A, go here to engine speed, click off the enable axes, go to inlet manifold pressure, turn off the enable axes, click OK. Now we're left with a single site of the table. We're now going to change this to 100% volumetric efficiency. We're going to store that to the Motec. Very first change. Next thing we're going to do here is jump into our estimate tuning, and in this particular window here, I have all of the details in order to turn things on or off or configure certain details for individual throttle body tuning. The next detail we're going to take a look at here is going to be into our engine, and then into the load and into the normalized option. So this is going to be telling the Motec what we want to use in terms of a load input to our spark timing table. Very important detail here, we don't want to forget to be able to update this. Currently this is set on a manifold pressure. If we go in here, it's set on inlet manifold pressure based. That's the typical option if you're tuning a single throttle body with an intake plenum. So in the event of individual throttle bodies, we're going to be setting this on a naturally aspirated engine we're going to be setting this the throttle position. We want this based via throttle position. So the index.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.